In the last geomorphology lecture, we are going to be talking about periglacial processes and landforms, which means permafrost. Before we get to the landforms themselves, let's just talk a little bit about what permafrost is. Permafrost is permanently frozen ground. And this doesn't refer to ground that's right at the surface. That's usually considered the active layer in permafrost. It melts every summer and then refreezes during the winter. Instead, it refers to ground that is sometimes many hundreds, if not thousands of feet deep underneath the ground that is frozen. This includes the frozen areas, which are sometimes great big huge blocks considered continuous permafrost, or just smaller blocks that are spread through an area which is discontinuous permafrost. Sometimes within the permafrost itself, there are open areas which are referred to as talic layers. Permafrost, as I said, is significant because it's ground that's frozen underneath the active layer. That active layer is a thin zone right at the surface that melts and freezes every summer. But because it melts and freezes without the opportunity for materials to move any lower than the active zone, it means that oftentimes larger materials, especially rock, get pushed upwards during the freezing and thawing process, and also cracks form as a result of ice wedging in the area. So ice wedging occurs because you have so much freezing and thawing and available water in that active zone. Oftentimes wedges form very small, forming cracks in the ground, but they can grow quite large as well, as shown in the diagram. And that ice wedging and the frost action and heaving of rocks and materials upwards can create some very interesting landforms. We already talked a little bit about permafrost before when we talked about mass wasting. The type of mass wasting that occurs in permafrost areas is solifluction, which is essentially the slow movement of soils in lobes downslope riding on top of permafrost, as you can see in the picture right here, as a result of the gelifluction of the soil, which essentially refers to it becoming jelly-like. And we'll talk a little bit more about that when we hit soils in the next module. Some of the landforms that are created in permafrost include small hills that are thrust upwards as a result of first the sorting of material, but then the construction of larger ice nodules under the ground that grow larger and larger over time. These are called pingos. Once they reach a certain height and a certain range, they often then start to see melting and they collapse, but these pingos can be quite prominent actually. Much closer to the ground surface is the creation of patterned ground and nets of stone that are sorted through the freezing and thawing process. And we see a picture of that patterned ground on the right here. In addition to the things that take place as a result of sorting of rocks and construction of ice, we often get very interesting looking oriented lakes and drainage patterns in permafrost areas because when wind blows over water during the summertime, it moves the location of the warmer water over areas of permafrost and melts it out underneath the ground and creates greater amounts of erosion in the active zone as a result of that wind action. So you get some sort of interesting drainage as well. We'll take a look at a map in just a second, but first here are just a couple of pictures of what's called a beaded drainage shown right here. And then this is a little image of a pingo that I created laying satellite imagery on top of a little surface model of the ground. In addition to permafrost being a natural feature, it's also a human feature as well. There's something called thermokarst, which essentially refers to the fact that when we build structures improperly on top of the ground, it often has really big impact on permafrost, leading to areas starting to subside and creating strange problems like you see in this cabin right here. Let's go quickly take a look at a map, though, of a permafrost area. This is up from the North Slope right now. It's called the Beachy Point A2 northeast quadrangle. And we can see really good examples of oriented lakes in here that are caused because you have permafrost underneath the ground. There are also likely a large number of pingos that are here that aren't going to show up because the contour lines just aren't large enough to really show that. If we zoom in a little bit and look at some of the areas that have slightly finer amounts of materials underneath the soil, you can see that pattern ground shows up even in this what's called an orthographic map, which puts an orthographic image on top of the topographic map, allowing us to see vegetation patterns and some of that pattern ground under here. So these are all good examples of permafrost landforms found on this map, and probably a lot of things that we can't see here too. So those are the key landforms associated with permafrost, and we are done with geomorphology now, and we'll start in on soils and terrestrial biomes for the next module.